Good morning, everyone. We're very glad to be here and talking to you about this technology. We are obviously very excited about it. I'll walk you through some of the stuff that we went through to get to this stage, and we will be happy to hear your questions later on or comments if you have. So if you don't remember anything else from this talk today, remember we're going from pig to poop to product. And well, our adhesive, as Chad mentioned, is a low-cost, durable, and green adhesive. So when you talk about the adhesive for construction, I'm a material scientist, so my focus was to create an adhesive that doesn't depend on petroleum crude oil, simply as simple as that. I wasn't focused on agriculture, treatment, or anything on that side. It just happened that we are here with the pig manure today. So we look at the supply side. We have 6 billion gallons of swine manure in the United States, and it comes with a lot of environmental pollution, and manure storage and handling is a challenge for farmers. We had a couple of collapses of the lagoons, and so forth. If you are from Pennsylvania, we have a lot of hog farmers here. We have a lot of those in North Carolina. We are actually the second producer of pigs. We found out even to North America Manure Expo last year, and we actually found out that the limit on how big the farm can grow is not the number of pigs, but how well they can manage the manure, which was interesting to know. And from the demand side, all of us depend on crude oil. We need it for fuel, oil, and other stuff. We also need it for adhesive. The petroleum-based adhesive are the main adhesive we are using today in carpeting, flooring, roofing, asphalt construction, and so forth. So the glue that we put actually together with the stone particle to make our asphalt pavements are the glue that we are targeting for the first market. We have 4 million miles of highway in the United States, which we use to maintain them. We need $10 billion per year. And the price of asphalt, if you guys are familiar with this market, it has been going up ever since 2004. We had 250% increase in the price. And that's challenging with the budget cut coming and DOT having a certain amount of money. They can't maintain and build more roads because the price is going up and the budget is basically constant. So we are addressing two pains in both sides of supply chain, and it's very uniquely positioned in that sense. So our main value proposition is the price, obviously. When we talk to most of the construction crew, the first thing they were concerned with is the price. So our production is 70% lower in cost, and we also save on the energy consumption. If you're familiar with the asphalt construction, we place it in 311 Fahrenheit. With our process, we can place the mixture and compact it in 254, which is equivalent to almost $400 million per year saving for the industry as a result. When you actually heat it to lower temperature, you can also create less fuel and emissions, which is better for worker working on the job site and as well as the environment, because you get less CO2 back to the atmosphere. The third one is the reduction in maintenance, and this is our most technical part, that we reduce the cracking at low temperature, winters, and so forth. So 35% reduction in maintenance comes from the cracking reduction. And that will be equal to $11.2 million in maintenance fee cost, that is, DOT's spend on maintaining our roads. And our results has been validated with these universities, Illinois, Michigan Tech, MIT, and Massachusetts Dartmouth, as well as A&T. We went through all this round-robin testing to see if the cracking resistance is actually improved with this product. And as you can see in this slide here, we have the temperature for the cracking at typical asphalt is minus 17 degrees C. And when we add our product, just a little bit of it, and that's just 5% of our adhesive, it can reach to minus 21. And you can see this is significant in terms of states that are colder region, like Massachusetts, Pennsylvania to some extent, but Michigan and northern states that get very cold. We can reduce the cracking, which actually these cracks end up to be pothole sometime after that. with increasing the cracking resistance, we found out also we can use the recycled material more and more. Right now, most of the Department of Transportation, they are pushing the envelope of using recycled material into the new construction. And with this material, we can push the envelope further. Like I know in North Carolina, we are up to 30%, Texas pushing the envelope to 40–45%. And the limit on how far you can use the recycled material is the limit on the cracking resistance. The more you use recycled material, it's harder to control the cracking and keep the quality. So there's a compromise, it's a trade-off in a way. So we started using the recycled material here. This is 15% recycled material. And as you can see, the temperature, cracking temperature will be reduced in the conventional. But we added our adhesive, and now we are up to -20. Of course, it's a reduction from the control to 15%. And then we say, okay, if we are improving this cracking resistance, can we push the envelope even further? And we went to 45% here. You can see the control asphalt. This is the typical asphalt, PG6422, very commonly used in a state like here or North Carolina and so forth. And that will drop to this. And with adhesive that we are adding, we can get to -16. Interesting part is 15% recycled material, it was almost equal to 45%, which is the last row here. So you can push the envelope of recycling using recycled material without compromising the performance, which was a very big, appealing feature for states like Massachusetts that are concerned and they are limited with this cracking resistance, are called the region. Of course, the adhesive we are making, it meets the specification for the DOTs and application on the roads. We have a certification on those. But everybody also, so is it asphalt? Well, it's not. It performs the same, it's mechanically the same, but chemistry of it is totally different. So you have a different material which behave like glue as you use for other applications. So we looked at the, I don't want to go too detailed on the chemistry part, but we looked at the proton NMR, and we found that there are a lot of unsaturated olefins which we don't have it in asphalt. But does it matter? In terms of the specification, it doesn't, because the spec that we have today is basically a set of mechanically driven tests. So you pass those tests, you're good to use it, and it performs the way you want it. And actually, honestly, the reason that we are using asphalt in our roads is cost-driven. So if you can get a glue that works better than asphalt and is the same price, they will be happy to use it. The only reason we are using asphalt is actually a very low-cost glue, and it performs the way to pass the spec, basically. The spec is based on that. So we also look at the saturated aromatic resin and asphalting components of several asphalt and adhesive. So these are typical asphalt used in the states, colder states here, and hot states like Texas here. And this is our adhesive, basically. So we have certain features that are similar to the asphalt. Of course, the percentage-wise is different. You have different percentage saturated aromatic resin and asphalting. But at the end of the day, it matters how it performs and how it passes all those specification criteria.